Y'all, so this is the optional video just to get some help on 210. I'm actually going to step through it step by step, so if you saw this, then good on you. You will have a step-by-step solution to one problem that I felt wasn't very straightforward, but it brought up a lot of interesting topics that are really good to review. So we have here that the slope of AB is 5 with points A at -3, -1, and B at 2, n. So we want to find the value of n, or find that y value for B, and we also, after that, want to find the distance between these 2 points. So we're going to first start off with the slope, so we're going to first find the value of n. So remember, slope is just the rise over the run, or the steepness of our line. If we wanted to find the rise over the run, say we have 2 points A and B, we need to take the difference of the x's for our run and the difference of the y's for our rise. So if we have an x-coordinate and a y-coordinate for both A and B, we can also see the slope in terms of the difference of our y values. So yb minus ya over the x-coordinates, the run, so xb minus xa. So notice how in this case we have our slope, we have our x and y values for coordinate A, we have the x coordinate for B, but we're missing the y. This is our n. So we might want to organize our information first. We know that our slope, which can also be seen as m, is equal to 5. We know that our x and y coordinates are -3 and -1 from right up here. And we know that our b coordinates are going to be 2 and that elusive n that we're looking for. So it's really just a matter of organizing your information, putting it in here, and then figuring out how to solve for that n. So I have my m, which I know is equal to 5, and I'm going to have this set equal to some ratio. So yb is our mystery n. We're going to subtract that from our ya, which is -1, and then we're going to divide that by our xb, which is 2, minus the x-coordinate of our first point, which is -3. We can spend a step simplifying, so really remember to keep your work nice and neat. We'll have 5 equal to n plus 1, 2 negatives make a positive, divided by 2 minus a -3, or 2 plus 3, so we got 5. So we can then multiply both sides by 5. These will cancel these out. Remember, multiplication undoes division. And we find that we get 25 equal to n plus 1. We subtract 1 off both sides. -1, these two cancel, and we get n is equal to 25 minus 1, or n is equal to 24. Awesome. So now that we have this, we can find our distance. And so let's get a very good picture of what's going on here now that we know the coordinates. Okay, so let's... Okay. So we got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so each of these are going to be 5s. Just notice how we have a big y value. We can actually scale our x's pretty decently. We know that one of our x's is -3, the other one is 2, so I'm just going to do some standard scales, and this is totally okay. We don't have to have the same scale for both axes. It might mess with how steep our line is, but the information still stays there. So I'm going to make each of these 2, or each of these hashes 1, so now I have a complete coordinate plane. I know my first point A is -3, -1. So we go backwards 3 and then just down here. So this is my point A. We found our point B. It's going to be over 2, and we found that n to equal 24. So over 2 and way up here at 24. So we have over 2 up 24. So our second goal here is to figure out just how far away A and B are from each other. So we're looking for the distance right here. And it turns out we can actually think about the Pythagorean theorem here. We have some sort of x distance going on here. We have some sort of y distance going on right here. So if we square this, add it to the square of this, we'll get the square of our distance. So the distance formula really comes from the Pythagorean theorem right here. So here is the formula. You're going to have our distance equal to the square root of our first distance. So this is going to be this value right here, the x value for B, minus the x value for A will give you the number of steps you need to go between -3 and 2. So we got xb minus xa, and then we want to square that thing. And then what we're going to do is add the vertical distance. So the difference between these two values are going to be the 24 minus the -1. Makes sense. If we're stepping 24 steps down and then another step, we've gone 25 steps. So just to give you the general formula, we have yb minus ya. And then we're squaring that thing as well. And so now that we have kind of a rationale for why we're using this formula based off the Pythagorean theorem, a squared plus b squared equals c squared, or if we take the square root, c is equal to the square root of a squared plus b squared, we'll see that the difference of our x's gives us that a, and the difference between our y gives us the b. And the d, the distance, is just our c. So we just plug in our values. This is all equal to the square root. I'm just going to fill in some stuff so I can quickly change out these. So our x value is 2. We're subtracting a -3 from there. And then right here we have a 24 for our y value, and we're subtracting a -1 from there. So I'm losing the colors at this point. We got the square root. 2 minus -3 is 5 squared, and then 2 minus -1 is plus 25 squared. So this is going to be the square root of 25 plus, I believe, let's see. Yep, 625, or the square root of 650. And it turns out this is about 25.5. So this distance is about 25.5 units from A to B, given this distance formula right here. So we talked about the distance formula. We once again reviewed our slope, except looked at it a little bit different of a way. So now you should be successful. And we actually did question 210.